which is my favorite subject, which is chemistry. I'm back with a new episode of chemistry, which is my favorite subject, and in this video we are going to discuss about three topics, which are law of conservation of mass, law of constant proportions, and Dalton's atomic theory. Dalton's atomic theory. In this video, we are going to discuss about these three topics. It will be very interesting if you understand. So without any delay, let's get into the video. Okay. What does the law of conservation of mass says? See, let's take two chemicals which are silver of 10 grams and bromine of 5 grams. What will you get? Silver bromide? Yes. How much weight it will be? What is the mass of the silver bromide when combined to this two? This will be 15 grams. Yes. So here, what is the mass of reactants? What are reactants? The substances which will be reacting at the first before a chemical reaction. Yes. Yes. See, here chemical reaction doesn't take place. So these two are reactants. What is the mass of reactants? What is 10 plus 5? This is 15 grams. And what is the mass of product? It is also 15 grams. So here, these both are equal. Yes. So mass is conserved. Yes. And mass of reactants is equals to mass of product. Yes. This is what the law of conservation of mass says. Okay. For example, let's take lead nitrate. 2 ppNO3 equal to, and potassium iodide. Let's take lead nitrate of 5 grams, potassium iodide of 6 grams, and we get potassium nitrate KNO3 plus lead iodide PbI2. Lead iodide. We get potassium. Let's take potassium nitrate is 7 grams and lead iodide is 4 grams. Okay. Okay. So is energy conserved here? Mass is conserved here. Let's check. What is 5 grams plus 6 grams? Here mass of reactants is 11 grams. Here 7 grams plus 4 grams, which is, so mass of products is also 11 grams. So thus mass of reactants is equals to mass of products. Thus mass is conserved. Yes. So law of conservation of mass says that mass or matter can neither be created or neither be destroyed. Neither be created nor be destroyed. In other words, mass of reactants is equals to the mass of products. This is what law of conservation of mass says. Okay. Okay. Then what about law of constant proportions? What? See, matter can neither be created nor be destroyed. Yes. See, then you can ask it out. If we burn a paper, it becomes ash. Then where is the paper? Matter has destroyed. You can ask this question. Yes. But at least in the ash form, the paper exists. Paper exists, but in ash, in the form of ash. When you blow it off, it again exists. It will be exist in small particles which will be microscopic or macroscopic. It will be existing. It is not. It can't be destroyed. Yes. If you vaporize the water, water will be. But it at least exists in the form of a vapor. Water exists in the form of vapor when you heat it. It is not destroyed. It exists in different form rather than the original form. So that is what here law of conservation of mass states. What about law of conservation of mass? What does this say? can neither be created nor be tested in a chemical reaction, or in other words, mass of products is equal to the mass of reactants, or mass of reactants is equal to the mass of products. This is what the law of conservation of mass states. Then what does law of constant proportions state? Law of constant proportions states that a given chemical substance or given chemical compound always contains the fixed proportion of their mass or ratio. Yes? See, when you take water, H2O, here if you are drinking water right now, this forms H2O, and what is the ratio of this? What is the atomic mass of hydrogen? It's 2. Yes? Atomic mass of one hydrogen is 1 AMU. Then 2 hydrogen is 2 AMU. Yes? 2 is to hydrogen is to oxygen mass in H2O is 2 is to what is the atomic mass of oxygen? It is 16 AMU, which is 1 is to 8. This is the ratio. Yes? 1 is to 8. This is the ratio of hydrogen is to oxygen in water. If you go to Himalaya and if you see the water there, same proportion, same ratio. If you go to like Mount Everest, their water will be somewhat their same ratio. Yes, if you go to America, if you go to New Zealand, water will be of same ratio. It will be constant. The ratio of masses and proportions will be constant, and that says law of constant proportions. I am repeating the statement of law of constant proportions again. A given chemical substance or a given chemical compound contains the fixed proportions of ratio of their masses. This is what the law of constant proportions says. For example, if you take carbon dioxide, CO2, what is the atomic mass of carbon? It is 12. Is to what is the atomic mass of dioxide? It is 32. Yes? So 12 is to 32, which is 3 is to 8. Yes? This is the ratio of carbon dioxide of their masses. Yes? Again, if you go to like space, there will be no air here. If you go to Antarctica, their carbon dioxide ratio will be 3 is to 8. If you go to New Zealand, their carbon dioxide ratio will be 3 is to 8. I am excelling. This is carbon dioxide. When it is 3 is to 8, wherever you go, a given chemical substance or compound contains a fixed ratio of masses of their molecules and atoms. This is what the law of conservation of mass, law of constant proportions states. Yes, I think you have understood what are these two laws, and Dalton's atomic theory is nothing but the combination of these two laws will be Dalton's atomic theory. Let's see the postulates, 5 postulates of Dalton's atomic theory. Let's observe the 5 postulates of Dalton's atomic theory. So let's look at the 5 postulates of Dalton's atomic theory. First postulate: atoms are neither created nor destroyed. This is related to law of conservation of mass. Atoms are neither created nor destroyed in a chemical reaction. Yes, the first postulate. Okay. A matter consists of small indivisible particles called atoms. Matter consists of small indivisible particles. Let's take this is the matter. In this, so many molecules. Yes, in a molecule, so many atoms. Yes, and in an atom, nothing. This is indivisible. Matter consists of small indivisible particles called atoms. What are they? Atoms. This is the first postulate of Dalton's atomic theory. The second postulate is atoms atoms are neither created nor destroyed in a chemical reaction. Only reorganization of chemicals or substances or elements or compounds are occurred in a chemical reaction. This is the second postulate. What does the second postulate says is, it is ditto of law of conservation of mass. Yes, atoms are neither created nor destroyed in the chemical reaction. Only reorganization, which is double displacement or single displacement, reorganization occurs in a chemical reaction. This is developed by second postulate of Dalton's atomic theory. This was proposed by John Dalton. Okay. Third postulate. The chemical change is the union or separation of chemicals or atoms of fixed whole number ratios. Yes, this is the third postulate. Yes, so third postulate, I repeat, that was the fourth postulate, I have just confused. The third postulate is, atoms of same elements have same identical mass and chemical properties, and atoms of different elements have different identical mass and chemical properties. What does this say? Let's take an atom of carbon and nitrogen and carbon. Okay, two atoms of carbon and nitrogen. Now, what is atomic mass of carbon? 12U. Yes. What is atomic mass of nitrogen? 14U. Yes. See, atoms of same elements, carbon and carbon, they are same elements. They have same masses. They have same chemical properties. Their valency is 4. Yes. So they have same chemical properties. They have same atomic mass and identical mass. So atoms of same elements have same atomic identical mass and chemical properties. But carbon and nitrogen, their atomic mass is different. Their chemical properties will also be different. So these are different. This is what the fourth postulate of Dalton's atomic theory states. Third postulate of Dalton's atomic theory states, atoms of same elements have same chemical properties and identical mass. Atoms of different elements have different chemical properties and identical mass. This is what the third postulate of Dalton's atomic theory is. Next, fourth postulate. What does the fourth postulate states? Compounds are formed when atoms of different elements are combined in a fixed whole number ratios. That is, chemical change is the union or separation of atoms as in whole numbers. This is the fourth postulate of Dalton's atomic theory. What does this mean? See, compounds are formed. See, let's take compound carbon dioxide or lithium hydride or carbon monoxide or water, HOH or H2O, and also what we will take more? Magnesium oxide. Let's take these 5 compounds. Carbon dioxide. Yes. So what is the ratio of carbon dioxide? Just we have discussed. What is the mass of carbon? It is 12 and is to 32. Yes, two atoms of oxygen. One atom of oxygen is 16U and 2 atoms of oxygen is 32U. 12 is to 32, which is 3 is to 8. This is the ratio of carbon dioxide. Lithium hydride. What is the atomic mass of lithium? It is 6U. 6 is to 2, which is 3 is to 1. This is the ratio, yes, of lithium hydride. I am talking about atomic masses. I am not talking about these ratios. No, I am talking about ratios of atomic masses. Here, this is 12 is to 16, which is 3 is to 4. Here, H2O. This is correct. Let's take this one. It is 2 is to 16, which is 1 is to 8. What is the atomic mass of magnesium? It is 24 because its atomic number is 12. 12 into 2 is 24. Yes, 24 is to 16. Atomic number of oxygen is 8. 8 into 2 16. 24 is to 16, which is 6 is to 4, which is 3 is to 2. Yes. So see, all are in whole numbers. Yes. All will be in whole numbers. Ratios itself. This is what the law of the fourth postulate of Dalton's atomic theory states. Compounds are formed when atoms of different elements combined in a fixed whole number ratios. Yes, see, there are different elements like carbon and oxygen, lithium and hydrogen, carbon and oxygen, and hydrogen and oxygen, magnesium and oxygen. There are atoms of different elements. They are combined in a fixed whole number ratio. Yes. So this is what the fourth postulate of Dalton's atomic theory states. There is another statement of fourth postulate, which is chemical change is a union or separation of atoms in a combined whole number ratios, in a fixed whole number ratios, as in whole number ratios. What does this mean? Okay, let's take carbon dioxide. It is a white color precipitate. Carbon monoxide, it is a black color precipitate. See, chemical change or color change. Why? This is the separation of oxygen. There are 2 atoms of oxygen, there is only 1 atom of oxygen. Separation of atom takes place. Let's take, this is not LiH, this is LiH2. Oh yeah, this is 6 is to 2. 3 is to 1. Okay. So LiH2, lithium hydride. Okay, and let's take H2O. Let's take H3O, hydronium ion. H2O to H3O, hydronium ion. This property changes. Let's take D2O, which is heavy water. The deuterium, the second isotope of hydrogen is D. Yes, deuterium. H21. Yeah, I will make a separate video on isotopes too. Okay. So heavy water. What is the difference between water and heavy water? Everything is same. Everything is same except one. What is that exception? The reaction of water is very fast when you dissolve salt in water. Yes, when you dissolve sodium chloride in hydrogen hydroxide, it dissolves very fastly. But when you dissolve in hydrogen hydroxide, heavy water, which is deuterium, D2O, deuterium oxide, it takes some time. That takes less time than water to dissolve the sodium chloride or table salt. So the reaction of water is very fast and the reaction of heavy water is little slow. Okay. So I think I have understood chemical change is the union of separation of atoms as in whole number ratios. So let's revise the fourth postulate. Compounds are formed when atoms of different elements are combined in a fixed whole number ratios. That is, chemical change is the union or separation of atoms as in whole number ratios. This is the fourth postulate of Dalton's atomic theory. And we have reached the last postulate, which is fifth postulate of Dalton's atomic theory, which is Dalton's atomic theory states, when atoms of different elements combine in a fixed whole number ratios, they form compounds. This is same as the first statement of fourth postulate of Dalton's atomic theory. Yes, when atoms of different elements combine in a fixed whole number ratios, they form compounds. This is the fifth postulate of Dalton's atomic theory, and we have completed the theory of Dalton's atomic theory. Okay, so I hope you have enjoyed and have gained so much of knowledge by this video which I have made now. And a small thing and small wish, happy Mahashivratri to all you, not only Hindus, all the Muslims, all the Christians. Do not fight for your religion, be safe. Happy Mahashivratri to all of you who are watching this video. So thank you for watching till the end. With the leave sending off your logical brilliance. Thank you for watching till the end.